Hey guys, this is Mr. Young. Today we're going to be talking about equations of perpendicular lines. Earlier this week we talked about parallel lines, and remember we said when you're talking about parallel and perpendicular, it is all about slope. Okay? Same applies with perpendicular lines. It is all about the slope. Okay? Parallel lines we said had the same slope, but we're going to see that perpendicular lines are a little bit different. Okay? We're going to learn how to identify perpendicular lines from their equation and graph, and we're going to learn how to write the equation of a parallel line. For me, this is my second time doing this lesson. I just recorded it a short while ago, and the video just disappeared into nothingness. So I'm doing this again, and I hope I do it as good as the first time. I guess we'll say that was practice. But anyways, I already know that we have an upcoming mistake. So let me go ahead and correct that. This is what are perpendicular lines. So let's change that real quick. Perpendicular lines. These are two non-vertical lines. Again, we're looking at lines that you can actually write the slope for. Remember, not vertical lines have an undefined slope. So we can't write their equation in slope-intercept form, so those are not the type lines that we're looking at. It doesn't mean that a vertical line cannot be perpendicular to another line, because it is. A good example is your x and y axis. The vertical y-axis is perpendicular to the x-axis, which is a horizontal line. So basically, I hope with that hint that you're thinking, hey, these perpendicular lines, they intersect at a right angle. They intersect at 90 degrees, okay? And that would be true. Now, if I'm looking at the slopes in the coordinate plane, or even from given equations, two, see now I'm yawning, two non-vertical lines in the same plane have slopes that are negative reciprocals. Well, if that's the case, then the lines are perpendicular. And by negative reciprocals, we can also refer to that as opposite reciprocals. But that just means that if I have a slope like 2/3, well, the opposite reciprocal for that is just flip it over and change the sign. So if I had a slope of, say, 2/3, then I would simply flip that over, which means take the bottom number and put it on top, and take the top number 2 and put it on the bottom. And if this were a plus 2/3, well, then I'm going to change the sign and make that the opposite reciprocal. Remember that word reciprocal? It just is a big word, but it just simply means flip it, okay? So I want you to write that down, flip it, and change the sign. Okay? So we flip it, change the sign. If two non-vertical lines in the same plane, okay, they have to be in the same plane. That's a geometric specification. And a plane would be like your sheet of notebook paper laying on a desk. The lines on your notebook paper are parallel lines, and they lie in the same plane on that same sheet of paper. But if two non-vertical lines in the same plane are perpendicular, then their slopes are negative reciprocals. Okay? So two lines that are perpendicular on your paper would be like the red margin lines with the blue writing lines. Those would be perpendicular to each other. Okay? So here we're looking at how to write a perpendicular slope. And we just talked about that briefly on the last slide. So we're given this slope m is equal to 5/7. Okay, and we'll go ahead and write that out. Okay, so this is 5/7. Okay. And then we want to write the perpendicular slope. Now, there's a notation for that, okay? we can use a little subscript of this symbol, which means perpendicular to. So a subscript just tells you which one. Which one are you looking at? In this case, a slope. And which slope? What's the perpendicular slope? And guys, I keep yawning. Oh my goodness. Anyways, so if I want to write the perpendicular slope to that slope given of 5 over 7, we said you first have to flip it. Okay, that means that bottom number 7, our denominator, gets written on top. And our top number, the 5, our numerator, gets written on the bottom. Okay? And this is understood, the given slope, to be a positive slope because we don't have a sign given in front of it. So we're going to change that sign because remember, we want the opposite reciprocal or negative reciprocal, which means once we flip it, we change the sign. If it's positive, we make it negative. And if it had been negative, we'll make it a positive. Okay, so that is your perpendicular slope. The next one, write the perpendicular slope to a line with slope m equal to a negative 5. And some of you, it's probably popping into your head already, wow, a negative 5? That's not even written in fractional form. How am I supposed to flip the 5? Well, guys, any integer that you're given, like a negative 5 or a positive 3 or anything like that, we can write in fractional form, and it's actually really easy, okay? All you do is put the given number over 1, because we know any number divided by 1 is that number. Any number multiplied by 1 is that number. So we can write it in fractional form by simply putting it over 1. And now we're ready to write the perpendicular slope. And if I write the perpendicular slope on this one, remember we're doing opposite reciprocals. Okay? So if I flip it, I'm going to take the bottom number and put it on top. And we're going to take the top number and put it on the bottom, which is a 5. And again, we're talking about the numbers right now. And we want the opposite reciprocal, so we're going to take the sign. The given slope is negative, so this one must be made positive. Okay? So that gives us a negative reciprocal, and that would be the perpendicular slope for the given slope. So let me show you something else. If two slopes are opposite reciprocals, then I can easily tell if two slopes are perpendicular by simply taking the product. Okay? So if I take these given slopes, in this case, 5 over 7, and I multiply that times the negative 7 over 5, then the 5's cancel, the 7's cancel, and we're left with a negative 1. So if I have two slopes, and I want to know, are these slopes of perpendicular lines? All I have to do is take the product, and if I get negative 1, then yes, those lines would be perpendicular to each other. And guys, I also want to tell you that parallel lines, there was a certain specifications. It had to have different y-intercepts. This is not the case for perpendicular lines. They could actually intersect on the y-axis, and those two lines would indeed have the same y-intercept. So that is okay if you're talking about perpendicular lines, for them to have the same y-intercept. But the slopes would be different in this case. So let's look at the next one, okay? So we're going to look at 1/5. We're going to multiply that times negative 5 over 1. But I want to do this one a little bit different. If you recall, multiplying fractions, you actually do a 1 times negative 5. So we multiply the top numbers and put it on top. and we multiply the bottom numbers, 5 times 1, and put that on the bottom. And negative 5 over 5 is just equal to a negative 1. So again, I can easily tell that those right there are perpendicular. Okay, and also that's a good way to check your work when you're writing the perpendicular slope. Now I'm going to let you pause the video real quick, and you guys can take these two given slopes, m sub 1 and m sub 2. That would be for like lines 1 and line 2. And I want you to see if those are perpendicular slopes. And you can use the technique we just did. You can take the product and see if you get a negative 1. Okay? So you can pause the video now, work that on your paper, and then when you're ready, hit the play button and continue on with the lesson. Okay, guys, I hope you did a very good job. I hope you took the product okay. And we're going to take the product of these two given slopes. And the first slope is given to be 3/5. So we're going to write that down. And I'm putting these in parentheses. And the next one is negative 5 over 3. Okay? So we said you can multiply the top numbers. So that's 3 times negative 5. And you put that on top. That's going to be a negative 15. The bottom numbers are 5 times 3, which is also 3 times 5. And that's also equal to 15. And that gives you a negative 15 divided by 15. And any number divided by itself is a 1. So this is indeed equal to negative 1. So that means that these are indeed perpendicular lines. Okay? Most definitely perpendicular. Okay? So moving on. How do we identify perpendicular lines in the coordinate plane? Well, you guys know from before that I can find the slope of the line that's graphed. And we said perpendicular, you should be thinking slope. And if I can find the slope of each line, then I should be able to write the slopes and take their product. And if I get negative 1, or I by observation see that these are indeed negative reciprocals, then I can indeed say that these are perpendicular lines. Okay? So first of all, we're going to label our lines. So this one we're going to call line number 1. And the one up here we're going to call line number 2. Okay? So if we first look at line number 1, then we want to know what is the slope of line 1. And you guys, you should be able to identify 2 points on the line that intersect where the grid lines intersect each other. Okay, and I hope you're seeing those 2 points now. So look at line number 1. See if you can identify 2 points that you would use. Now you might identify different points than myself, but that's okay. But look real close on that line. 1 point is right here. A second point on the line would be right here, right on the y-axis. And then there's another one up here. You might have picked the second 2 or the first 2. That's okay. You can work with either one. I'm going to work with the first 2 here since I wrote line 1 over there. So if I want to look at rise over run, then my rise, I can go up. And then my run, I'm going to go over to the right. Okay. And you can easily see that the rise is equal to a positive 1 because that's going up. And my run is a 1, 2, 3, 4. So that is a positive 4. And rise over run, remember that is our slope. So that's going to be a 1 over 4. Okay? And switching colors here, we're going to look at line number 2. So we want to write the slope for line number 2. So look at line number 2. Do you see 2 points that you would use in this case? Okay, look real close. I'm seeing 1 right here on the y-axis. I'll color that in. There's 1 way down here. Notice that one. And there's also 1 right up here at negative 1, 5. And I think I'm going to use that one. Okay. Now I could come over here and do a rise and run. And so you can see it better, I'm going to do my run first because it doesn't matter what order you do that in, as long as you put them in the right spot when you write the slope. So my rise is 1, 2, 3, 4. Again, that's a positive 4. My run is actually a negative 1. And you can tell that this is a negative slope. So rise over 1 is a negative 1 over... I'm sorry, I'm doing that wrong. Didn't do that on the other video. Well, the rise is positive 4. It goes on top. And the run is a negative 1. And again, we don't leave the negative on the bottom, but also 4 divided by 1 is 4. So we're going to make this equal to negative 4. Okay. Now, if I want to check that these are perpendicular, I can take the product. And that's going to be 1/4 times a negative 4. And we're going to go ahead and put that over 1 like we did before. And we see that 1 times negative 4 is negative 4. And 4 times 1 is equal to a positive 4. So the product is negative 1. And we'll say yes, these are perpendicular. Okay. And there you have it. So all you have to do is find the slope of the line, okay? And then you can write the slope for the first line, write the slope for the second line, then take the product of the two, and if you get a negative 1, then those are indeed perpendicular lines. Now don't assume they're perpendicular because they look it, because if you have 2 lines intersecting like maybe at an 89-degree angle, not quite 90 degrees. This is 90, but 89 degrees, it's going to look real close, but it will not be perpendicular. So you have to be very careful to check it. All right. All right, moving on. We're talking now about how to recognize perpendicular lines from their equations. Okay. So their equations. How are we going to do that? Well, we're going to look at 3 different lines. We said when you're given the equation of the line, you want to put it in a slope-intercept form. Why? Because perpendicular and parallel is all about slope. And slope-intercept form, which is your y equals mx plus b. I'll write that up here. Y equals mx plus b form. That slope-intercept form allows you to easily identify the slope of the line, okay? So first of all, we're going to notice that on line B, do you see the slope? I'm going to put that in blue. So what is the slope of line B? Do you see it? Remember, it's the number that multiplies x. Do you see that? So your slope for line B, it's already in slope-intercept form. Y is by itself on one side of the equation. So y is sitting over here by itself, and your slope is sitting right here beside the x. Okay? So it's equal to a positive 4. All right? Now the other 2 lines, A and C, we're going to have to do a little bit of work on those. Okay, you will. So line A right here, we'll do it in a different color. We're going to have to rewrite that equation, okay? Now, to save some space, I'm going to go ahead and tell you I'm going to move this negative 3y to the right-hand side. And what is it we said? When I move a term across the equal sign, it has to change signs, okay? So 12x equals, because I didn't move the 12x, but the negative 3y is on the right-hand side now, and it becomes a positive 3y. And then the 3 stays there. It's going to still be positive. Now I want to subtract 3 from both sides. Okay. That goes to 0. And we have 12x minus 3 is equal to 3y. And remember, how do I get y by itself? We said 3y is the same as 3 times y. So 3 multiplies y. Do you recall what our opposite operations are? Remember we said add is opposite of subtract, and multiply is opposite of divide. So if I have a multiplication, I get rid of that 3 by simply dividing it. Do the opposite operation. And we're going to divide the 3 into each term because I want to get that slope, okay? So I have to simplify it by simplifying each term. And we're going to get y equal to 12 divided by 3 is 4 times x. And negative 3 divided by 3 is a negative 1. So do you see the slope of line A? Do you see it? Are you looking right here? It's the number multiplying x. So our slope for line A is equal to a positive 4. And I'm just going to keep those over on the right as we find them. Now our last line, line C, we'll do this one in red. So I want to write this one. I got 4y plus x equal to 8. I'm going to move my x to the right-hand side. So if it moves across the equal sign, that's right, we change the sign. 4y stays right there. I get a negative x plus 8. And then I'm going to divide by 4 in every term. And remember this, minus x is really a minus 1 times x, okay? And that gives you 4 divided by 4 is 1 times y is y. And I get a negative 1/4 times x. And then 8 divided by 4 is a positive 2. But I want the slope. And do y'all see the slope? It's sitting right here. Do you see it? That's right, it's right here. The number that multiplies x, okay? So that is a negative 1/4, okay? Now the thing that should be standing out to you right now is the fact that slope of line A and slope of line B are both 4. Those have the same slope. So we can say that line A is parallel, and that's the symbol for parallel, but it's parallel to line B, okay? Now what about perpendicular, okay? Well, if you take that 4 and put it over 1, and you flip it, that would be 1/4, and you change the sign, that would be negative. Well, that would be the same slope as negative 1/4, which is the slope of line C. So what that tells you is line C is indeed perpendicular to line A, but also to line B, okay? Why? Because A and B are parallel. So if it's perpendicular to line A, it has to be perpendicular to line B, because line A and B are going in the same direction. All right? So again, If you don't have your line given in slope-intercept form, it takes a little bit of work, a little bit of algebra. And guys, just like before, I told you there's no putting this on Desmos, okay? By the time you get y by itself, which will be the testing version of the app, requires that, you can read the slope straight off the equation. So there's really no need, unless you want to check your work by simply graphing line A, B, and C that you found and see, okay, how did it turn out? Okay, that might be a means of checking your algebra just to see if you get anything remotely parallel and perpendicular, okay? Because if you didn't, maybe you made a mistake, or maybe it's correct. You know, it could be neither. You know, it could be that I had one of these as a slope of 3, and then that line wouldn't be parallel or perpendicular to B or C, if that was the case for slope A, B, and 3. So again, it's let the problem be what it is and just work it as such, okay? Now it's your turn, okay? This wants you to determine which of the following lines, if any, are parallel or perpendicular, okay? So you can take each line. Each of these is given in standard form, so you have to put them, well, except for line C, not quite standard form. But each of these needs a little bit of work to put it in slope-intercept form, okay? Once you have slope-intercept form, remember you're identifying the slope for line A, the slope for line B, and the slope for line C. And you want to know what are each of these. Once you determine those, remember it'll be the number multiplying x once you have y by itself on one side of the equation. Once you have your slopes, look at them, examine them. Do you have any that are the same slope? If you do, those will be your parallel lines. Do you have any that are opposite reciprocals? If you do, those are your perpendicular lines. So now pause the video and work this out on your own paper. And again, the answer is included, so you'll be able to check your answer. All right. And when you're ready, click play and we'll continue on with the lesson. All right, guys, I hope you did well on that last problem. I hope you were able to transform those equations and write them in slope-intercept form and able to pull off each of the slopes and correctly identify which ones were parallel and perpendicular. And now we want to look at how to write the equation of a perpendicular line. Okay, not just identify which are parallel or perpendicular, but actually write the equation. This whole process is similar to what we did in the lesson on parallel lines. You're going to first identify the slope of the given line. For parallel, it was all about keeping the same slope. But for this, we're going to have to actually do something to the slope. You have to write the opposite reciprocal to get the parallel slope, and then use it and the given point to write the new line. So let's get started on this problem, okay? First of all, we want to identify what is our slope of the given line, okay? So you're given y equals 1/3 x plus 2. So what would be the slope on this line? Okay, I hope you're looking at the term containing x, because your slope is sitting right here. You do not want to include the x. It's just, oh man, I did that last time. Sorry. I want the pen. Our slope that's given is m equal to 1/3. Okay? So first I want to write the perpendicular slope. Okay? Now the perpendicular slope to 1/3 would be the opposite reciprocal. Okay? So the opposite reciprocal. All right? So I want to take that m equals 1/3. I want to flip it over. Okay. So that means the bottom number goes on top. The top number goes on bottom. And this was understood to be a positive slope. So to take the opposite reciprocal or negative reciprocal, I simply change the sign from positive to negative. That means my perpendicular slope is equal to a -3. Now I'm going to tell you as a warning, I would go ahead and cross through the given slope, okay? Because now you want to only use your perpendicular slope. Do not accidentally grab the parallel slope. So to help prevent that, go ahead and cross through it. And now you want to use your perpendicular slope, and you want to use the x and y given in your point that your new line has to pass through. And we're actually going to look at the slope-intercept form y equals mx plus b. So again, I hope you're memorizing this form because it shows up a lot. And now you simply treat this like a formula. You plug in all your known values and you calculate your unknown, which is this y-intercept b. Okay? So where you have a y, we're going to replace that with a 4 from our coordinate, the coordinate -3, 4. And then the m, we're actually going to use our slope, our perpendicular slope, which is a -3, and I'm actually going to put that in parentheses. I definitely put things in parentheses when I'm substituting a negative. I think that's safer to do. The x value over here on the coordinate is -3, so we're going to plug that in for x. And then we have plus b, okay? So once you have that written, it's a matter of simplifying and then solving for b. So the 4 we're just copying down. We're going to multiply -3 times -3. Well, a negative times negative is a positive, and 3 times 3 is 9 plus b. And now I want to move the 9 to the other side. And moving it over, that positive 9 becomes a -9 plus 4 is equal to b. Now, guys, a -9 plus 4, to add integers that have unlike signs, you simply subtract the 2, and you give it the sign of the larger number 9, which is negative. Okay? So 9 minus 4 is 5, and it is a -5. And I'm going to go ahead and put the b on the left-hand side because I like to write my variable on the left. Okay? Now you can write the equation of the line. So you're again going to look at this form, y equals mx plus b. And the perpendicular line is y equal to your slope, perpendicular slope. Again, don't grab the parallel slope. That's equal to a -3 times x. And b is equal to a -5. So that'll be a -5. And this would be your equation of the perpendicular line. And that would be my dog barking at who knows what outside. Anyways, moving on. This is 2 problems. You don't necessarily have to work both, but if you have some time, I would try it on both of these. But you can pause the video now, and I want you to try and write the equation of the line that passes through the given point that's perpendicular to the given line. Okay? Now, you're going to go through the same process we just did. If you need to back the video up and rewatch that section, that's okay. Or if you took good notes, you can follow your notes, and that's fine also. But at least pick one of these problems and work through it and see if you're able to do it. And I'm not going to work through it myself because the answer is given. You'll be able to check your answer there. But can you get that answer? Can you go through the process and figure out your perpendicular slope? Can you plug into y equals mx plus b with the given point and calculate your y-intercept and then write the equation of the new line, okay? But you can pause the video now and try and work this problem 3 or 4 or both if you feel that would be good practice. I think it would be, but again, pause the video, work these, see if you can get the correct answer, and then when you're ready, press play and we'll finish out our last problem of the lesson. Okay, guys, this is our last problem of the lesson, and I made this well, it's sort of a challenge problem. It's just these two lines are given in different forms. We have one line number 1, that is given in slope-intercept form, so we have the equation of the line, and line number 2 is given in graphical form, so we have the graph of the line. But are we going to let that hang us up? No, because we know when we're dealing with perpendicular lines, and they want to know are the two given lines perpendicular, we know that everything is about slope, okay? When you hear perpendicular, you should be thinking slope, okay? When you hear parallel, think slope, okay? So we need to first identify the slopes of the line, but I think there's an easier thing we can check first, okay? Line number 1, do you see the slope for line number 1? Do you see it? What is the slope for line number 1? Remember, it's the number that multiplies x, okay? So line number 1, if I write y equals mx plus b, I can actually write that over the equation, and then right here, the number in front of x, that is our slope. So the given slope here is 4/3, okay? Now, if I look at line number 2, okay? Well, first of all, I'm about to get ahead of myself. What would you say is the sign of slope number 1? Slope is, in this case, positive, right? Now look at line number 2. If I read this line, oh my Lord, my dog is barking at something. Calm down, Brutus. Line number 2, if I read from right or left to right, my line is going downhill. Do you see it going downhill? If I had a skier on here, do you see this? There's his little skis, little ski pole. He is going this direction, right? He's going downhill. So that means this slope is negative. Now, guys, if I check just the sign of the given slopes, and they're both positive, there's no way that two positive slopes can be opposite reciprocals, because that would defy the word opposite, okay? If I had two slopes that were negative, they cannot be opposite reciprocals. It would defy the word opposite. The fact that we have a positive and negative slope doesn't tell us they're perpendicular, but it does tell us they are possibly perpendicular, because they do meet the criteria of being opposite in sign, okay? So that means if I had two positive slopes, end of the problem. I can tell you straight away, not perpendicular. If I had two negative slopes, I can tell you straight away, definitely not perpendicular. But positive and negative, possibly. So we're going to actually finish the problem out. We've identified the first slope as 4/3, positive 4/3. And now we're going to look at the slope for line number 2. Okay? Line number 2, if I look at rise and run, my rise is right here. It's going down, and my run is going over to the right. Now this goes down 1, 2, 3. So this is a negative 3. And this goes right 1, 2, 3, 4. So that is a positive 4. So if my slope for line 2 is rise over run, then that means my slope for line 2 is a rise of negative 3 and a run of 4. Okay? Now, before we finish the problem, I do want to point out, okay, that I could have used my slope definition, m equals y2 minus y1 divided by x2 minus x1. So if I did that here, my slope would have been, let's say, 7 minus 4, your difference of y values, and then 0 minus 4. So I would have had 3 over negative 4, which is a negative 3/4. Okay? So you can calculate slope if you have 2 coordinates on the line. That is fine. Okay? But I just like doing rise and run because all I have to do is count, and that works out. Okay? And I can actually get the sign of the slope just from its graph. Okay, we just said the slope was negative. We didn't even have to calculate. If it's going downhill, it's negative. Uphill, it's positive. Okay? To finish out the problem, we want to take the 2 slopes, and we're going to take the product. Okay? And we want to know, do these equal to a negative 1? If they do, we have perpendicular lines. So slope number 1 is positive 4/3. Slope number 2 is a negative 3/4. Okay? And again, I can say my 3's cancel each other. My 4's cancel each other. And I get 1 times negative 1 is indeed negative 1. So I can say, yes, these are perpendicular lines. Okay? And again, not really going to check that on Desmos unless line number 2 you're going to actually finish it out and write the equation of the line, which we could do that because you've identified the slope. So I could come over here and say y equals negative 3/4 x, and your y-intercept is sitting right on the graph. That's at a positive 7. Okay? So I could graph those two and see, are those perpendicular? Okay? Again, graphing, you can't claim they're perpendicular, but it would be a good possibility if they have that perpendicular look. But again, you need to prove it by actually taking the product of the slopes. Okay? Don't just go by looks. Sometimes looks can be deceiving, which y'all know that. All right. Finally, in summary, recall perpendicular lines have the opposite reciprocal slopes, okay, or negative reciprocals, which just simply means flip it and change the sign. Okay? That is what opposite reciprocal means. Okay? If you are given 2 equations of the line, you need to make sure they're both in slope-intercept form, which is your y equals mx plus b form. Then you want to compare the slopes. You need to grab that number that multiplies x on each of the equations and check if they're opposite reciprocals. I can take their product and see if they equal negative 1, or I could take one of the slopes, flip it over, change the sign, and does that match the slope of the second line? If yes, then you have 2 perpendicular lines. Okay? Now, to write the equation of a line that's perpendicular to a given line through a given point, you follow the same process that we did for parallel lines, with the exception that you must write the perpendicular slope. Okay? So first of all, the equation given has to be in slope-intercept form so you can determine the slope of the given line. Then you want to write the perpendicular slope by flipping the given slope and changing its sign. Again, we're writing the opposite reciprocal. for the perpendicular slope. And then you're going to substitute that with the x and y coordinate. That's where you get your x and y values into your slope-intercept form and calculate b, the y-intercept. And once you have your b and your perpendicular slope, you can write the equation by plugging into slope-intercept form, y equals mx plus b, replace the m with your perpendicular slope, replace the b with the y-intercept you found, and then you're done. You will have successfully written your equation of a perpendicular line. And I appreciate y'all working so hard on this lesson. I've enjoyed it. I hope you did all as well. And I will talk to you on our next lesson. And I hope you do well on the assignment. It is a quiz. It is fine to do that tomorrow. And we'll see how you do. Again, I'll be online on Google Hangouts. If you need to contact me, just send me a message or send me an email. All right? Talk to y'all later. Thank you. Bye-bye.